All right, so we are going to be doing some water quality tests, and this is a sample of water that I went down to our beloved campus lake, not recently because I would probably fall in. I've got a thwarted center of gravity right now, but recently, before I was, so giant, I went down and got a sample from our campus lake. And as you can tell, it's kind of gross looking, right? There's algae, there's all kinds of stuff floating around in there. And we want to know what's in our campus water. Specifically, not water from our faucet, because that's processed by the city. What's in our drainage pond out there? So we're going to be testing today for several different things. We're going to be testing for sugar and protein. Why would those be things that you would expect to have in a pond? Well, I know that there are frogs and turtles and fish and all kinds of things in that lake, tadpoles, bugs, right? Both of those are going to be generating sugar. Both of them are going to be generating protein, right? Your fish poop and all that great stuff, dead stuff breaking down. So we're going to test for sugar and protein. And then let's test for some things that we don't want to be in our water. We definitely don't want lead ion in our water. Bad news, right? That's toxic, highly toxic. We don't want silver ion in my drainage pond there either. We need to call EPA if these come out to be positive. And then let's test for some things that are safe in a low concentration. The hydroxide ion, the carbonate ion. So what we're going to do today is we're going to do some simple water quality testing. I'm going to pause the recording so that you can make your predictions at home or in your classroom, and then I will show you what we're getting as our results. So let's first test for sugar. So hit pause, talk to your friends, person next to you, or if you're watching this at home, pause and think about whether or not you think this is going to be positive. And then once you've made a prediction, hit resume. So let's see what would happen if we have a positive sugar test. So what we're going to do, this is our lake water, right? That's what it looks like initially. We're going to add copper ion to it, which is blue, okay? It's called Benedict's reagent. So if we have copper 2 ion, now sugars are molecules that contain, let's sketch somewhere, they contain ketones and they contain aldehydes. Right, so there's whatever the chain is, there's the rest of the chain. So if you've got a ketone, that's what it would look like. If you've got an aldehyde, that's what it would look like. Now a ketone plus Cu2 plus, that's no reaction, right? But an aldehyde, and some sugars are not reducing sugars, meaning that they don't have a reaction. But the sugars of interest to us, as chemists, that would be present in a biological source, if we react them with Cu2+, here's what happens. This is called an oxidation reduction reaction, or redox. A redox reaction occurs where the aldehyde is oxidized to a carboxylic acid. This is your oxidation. And the Cu2+ is reduced to Cu+, and it actually precipitates out as Cu2S, C2O, excuse me. But it's a solid, which is red. So this is the reduction. So a positive test equals a red solid. Right? And a negative test, use the same notation, a negative test equals no color change. Now I'm going to start this one first because we have to heat it. Okay, this reaction needs to be heated. And so I'm going to do it first so it can be doing its thing off to the side while we're doing some of these other ones. So there's my Bunsen burner. Let's get gloved up. turn on some heat. Way too high, you can hear it, right? It's way too high. Just want a small source. You don't need to have an inferno. Oops. All right. Now what we're going to do, need to get some water here. We're going to use a water bath. We don't want to heat this directly. We're just going to use a water bath. I'm going to take a sample of my lake water. Okay, so here's my lake water going in. You don't need a ton of it. Okay, we're going to add our reagent. Again, note the initial color. This is what it was originally, kind of that yellowy color. We're adding blue to it. So if there's no reaction, it will stay blue. If that's a negative test, it'll stay blue. And if there's a positive test, we'll see a red, orangey red precipitate form. So we're just going to let that sit there. Move my reagent off to the side. And we're going to let that cook. Now let's talk about what test we'll do for the presence of protein. So we're also going to use copper to test for the presence of protein. Now, proteins are made out of amino acids. And we're going to really simplify the chemistry here, okay? Because this is not biochem class. We're going to really simplify the chemistry here. When you take copper 2 that's dissolved and you combine it with amino acids, a positive test is orange / purple, and negative, no color change. So what I would like you to do is pause the video now, decide, do you think there's going to be a positive test or a negative test based on the fact that this is from a lake, and then resume the recording when you're ready to see what happens. Okay, let's do this now for our test for protein. And again, this needs to be heated. So we're going to do these two first so that they can heat while we do our other tests. So there's our sample. Again, there's the initial color of just the lake water. Now we're going to add our reagent. And actually this is in alcohol, I mean it's in NaOH as well. So it is a basic solution. So there's our color initially. If we have protein in our water, we will see it change to like an orangey purple. And if there's no protein in the water, we'll see no color change. It will remain kind of that bluish color. So again, I'm doing those two first so that they can react while we do our other ones. Our other ones are going to be immediate results. We'll know right away. All right, let's talk about how we're going to test for lead. So lead ion can be precipitated out pretty easily. If you look at your solubility chart, PbCl2 is a precipitate that we would see right away. Solid, it would form immediately. And PbI2 would precipitate out right away, very easily noticeable. So if we add iodide or chloride ion to this, if there is lead, if this is dissolved in our water here, Pb2+, let's just add iodide. Okay, this will produce PbI2 solid, which is a yellow. And it's bright yellow. It's a bright yellow precipitate. You can't miss it. There's no missing it. So we'll know immediately, do I have lead in my water or not? So pause the video, talk to your friends, decide if this is going to produce a positive test or a negative test, and then hit resume when you're ready to see the result. So let's take a sample. Again, this is what it looks like initially, right? It's that greenish kind of color. Now let's add where are you? There we go. So my ion here that I'm adding is colorless, clear colorless. And I'm adding equal volume. And this is 0.1 molar, so that's concentrated enough to precipitate anything out if it's in there. Whew, breathe a sigh of relief. There's no yellow precipitate. Right, the yellowiness that you're seeing is the result of the fact that we had yellowy water to begin with. Right, you would see a bright yellow solid at the bottom of this test tube. It would be like mustard yellow at the bottom of this test tube. So thankfully for us, we can breathe a sigh of relief. This is negative. Yay, that's a good thing. So we got a neg test. And that's good. That's what we want. Okay, we want to try to test for the presence of silver ion. We're going to do something similar. We're going to precipitate it out really easily. We can add chloride. Iodide would work too. Ag plus AQ plus Cl minus AQ produces AgCl solid. And this is a white solid. Well, it's actually like a white gray. It's like a whitish gray kind of color. So that's what a positive test would look like. So what I'd like you to do is pause the recording, talk to your friends, or think about it if you're there at home, and then resume when you're ready to see the result. Right, there's our initial color, just like the previous one. Now again, we would see a white or gray precipitate at the bottom. I mean, it'll be immediate. We'll see it right away. And so let's get out my other one. There we go. It looks pretty similar. Clear colorless. Equal volume added. Whew, we can breathe a sigh of relief here as well. Right, there's no precipitate at all. No precipitate. That's a negative test. That's good news. That's very good news. All right, we've got boiling here. So I'm going to turn my heat off. There's enough radiant heat in there for that to continue being heated. This was negative test as well. Whew, good, 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 good. I will report to the president of the college that we have no lead ions, we have no silver ions, dissolved in our drainage pond. Yay! All right, both negatives. Now let's test for these two. These are safe in low concentrations. Hydroxide ion is present on a lot of places, right? And carbonate, if you have hard water, you've got carbonate. So both of these, if you've got it, it's no big deal. But here's the interesting thing. When you try to precipitate them out, we're going to use calcium ion to try to precipitate them out. If you take calcium ion and you add it to hydroxide ion, you get a white precipitate, which is white. If you add calcium to carbonate, and that's 2, by the way, you get CaCO3 solid, which is also white. So if you get 2 white solids, well, now what am I going to do? How can I distinguish this white solid from this white solid? Well, here's something neat that you can do. If you add acid, strong acid, right? So if we add, we're going to use HCl. This will produce bubbles. That'll produce bubbles, right? So we can distinguish the carbonate from the hydroxide. If we add acid to this one, we're not going to see bubbles because this is going to break down and we're going to get CO2 gas. We'll see some results that way. So what I'd like you to do now is, again, pause, think about what you think the answers are going to be. Is it going to be positive or is it going to be negative? And when you're ready, hit resume. All right. So let's take some of our lake water. Here is for test number 1. And this is a cleaner one. Here is for test number 2. All right, so we've got 2 initial samples here. Let's add calcium to them both. See what we get. Try to make it equal volumes. All right, so in our test for hydroxide and carbonate, I got a white precipitate both times, right? That milky color says, yes, there's a precipitate here. But how do I know, did I make calcium hydroxide or did I make calcium carbonate? Well, now, since both of these contain the same thing, I'm going to add some acid to it. Strong acid, hydrochloric acid. And see what I get. Now there are a lot more analytical ways that you could test for this. Can you see? We're getting bubbles in there. What we're doing is we made carbon dioxide gas. So that white precipitate definitely is a positive indicator for calcium carbonate, right? Because when we add strong acid, we got bubbles. They're very easy to spot. Now we could do some further testing to see if we've got calcium hydroxide in there as well. But I can tell you my best guess as a chemist is that the hydroxide ion in here is pretty low. And the way I can know that is by measuring pH, right? Because if the pH of this water is greater than 7, then I can conclude that there's a lot of hydroxide in here. And if the pH of this water is less than 7 or close to 7, I can conclude that there's not a whole lot of hydroxide ion in here. So take a second, decide, is there hydroxide or is there not hydroxide in decent concentration? I'm going to go grab some pH paper and then we'll decide. All right, so pH paper here. Let's get my gloves back on. This will tell us, is there a lot of hydroxide in this water or not? So we're going to take our sample, measure its pH. Let me get my indicator. All right, so this is really qualitative, right? There's our color scale. We're between 7 and 8, right? Probably about 8. So it's a little bit alkaline. If it was really high concentrated, lots and lots of hydroxide, it'd be up here. We're not near that color, so I'd say we're about 8. So qualitatively, we could conclude that the precipitate we got is most likely carbonate and probably not hydroxide. Now for our last test, let's go back and look at our results from here. Sugar test and protein test. These are pretty warm, but that's why I'm wearing some thermal gloves to protect me. This is our sugar test, and this is our protein test. We've got pink, well, that's kind of like purpley. So that's a positive test. Well, it's like orangey, I guess, really. And then here, we've got that red precipitate. So are these positive tests or negative tests? This one is a positive test. And this is a positive test. This we're going to conclude is negative because the pH is about 8, which is kind of where you'd expect it to be for a lake. And this is a positive test. Because we got bubbles. And makes sense, we've got hard water in this area too. So we had 1, 2, 3 positives and 1, 2, 3 negatives. So I hope this little experiment gives you a greater understanding of solubility rules and how we can qualitatively test for the presence of ions. If you have follow-up questions or you want to ask more stuff about it, please feel free to email me, contact me, come see me. Otherwise, I hope you enjoyed our science. Have a good day.